Hello all, welcome back to Quest 0. Today's session will continue with the projection of planes. We'll look into a very different type of problem today, wherein an isosceles triangular plate of negligible thickness has base 25 mm long and altitude 35 mm. It is so placed on HP such that in the front view it is seen as an equilateral triangle of 25 mm sides, with the side that is parallel to VP being inclined at 45 degrees to HP. Draw its top and front views. Also determine the inclination of the plate with reference plane. So, the first thing is we'll draw the XY line, mark XY, VP and HP. Then consider an isosceles triangle like this. Like if we proceed like how it was in the previous problems, we need to place this isosceles triangle parallel or resting on HP on its entire surface. But if we do like this, in the front view, in both the first position and the second position, the triangle will be seen as a straight line, which is not the given condition. The given condition is in the front view it is seen as an equilateral triangle. Hence what we'll do is we'll draw this isosceles triangle in the VP plane by making the entire surface parallel to vertical plane, but also making sure that one of the corners touch the XY line since the surface is resting on HP. Okay, so we'll draw an isosceles triangle. I've already marked the base, which is of 25 mm. Since the triangle, in order to look like an equilateral triangle, if you consider this, and the equilateral triangle is of 25 mm side, the base is of 25 mm. So, providing inclination to the corner at a particular inclination, this triangle will begin to see as an equilateral triangle. We need to determine that inclination as well. Okay, these two edges will reduce in length whenever there is an inclination, and this length, whenever it becomes 25, we obtain an equilateral triangle. Since the base edge is being parallel to VP, it will always remain 25. Okay, so draw an isosceles triangle first. So initially draw the 25 mm line, mark A dash and B dash, and measuring the midpoint of 25, which is 12.5, draw a 35 millimeter line with a 2H pencil. Draw a 35 millimeter line. With a 2H pencil. Connect the third corner with a 2B pencil to B dash and A dash. Okay, so this is C dash. The isosceles triangle is ready. Now, we need to project this isosceles triangle onto the top view. So, in the top view, it is again seen as a straight line. With a 2H pencil or HP pencil, very lightly draw the line considerable distance away from XY line. With a 2B pencil, draw the projection. Okay, since it is lying on HP, if we draw it on the XY line, then it becomes lying on VP as well. So we don't want that. So this line, let us name them. So when you see from the top, A dash is visible, but B dash lies exactly behind A dash. Hence, B dash is not visible, hidden, denoted in brackets. This is C dash. Okay. This completes the first position. In the second position, we need to proceed with the front view itself this time around, wherein we need to make the triangle equilateral by lifting the C dash. So what we'll do is we'll draw an equilateral triangle in the second position. So I'll take the reference or projection from A dash, since it is at 25 millimeters above the XY line. I'll also mark the 35 mm line. Okay, so this is 35 filled arrows. $35. Okay. Now we'll proceed further with the second condition, wherein the triangle is seen as an equilateral triangle. So an equilateral triangle of 25 millimeter side. We already have the line at 25 millimeters. Okay. From that, it's slightly deviating. It is not being exactly parallel. Yes. This is the reason why I say you need to maintain the parallel lines properly in order to obtain the good results. I've shifted to a roller scale since it will be more easier to draw the parallel and perpendicular lines in that particular scale. Now, since equilateral triangle needs to be drawn, I don't know if I've drawn this exactly parallel to this. Okay, fine. Acceptable. Okay. Now, measure the length with your compass. Cut 2 arcs until it intersects the other arc. Now you will obtain the third corner, which is C dash. Join these to form an equilateral triangle. Okay. So this is C dash, A dash, B dash. Okay. Now, this line will not change its length. It will take an inclination. Okay. So what we'll do is, we'll draw the line, projection line from C dash, V dash. Okay. And intersect the projection lines from the first position. I'll extend C dash's projection, since B dash, A dash will remain grounded to HP, but C dash will be lifted. Okay. So now I'll measure A dash, B dash and C dash, the length from the first position. From B, cut an arc. So these are all not with the prime. These are all without prime since it is the top view. This is A, so 2V pencil, A in brackets B, C. Since top view, we don't draw the prime, we don't denote it by a prime. Okay. With a 2H pencil. Now connect these 2 points. This point being A comma B and this point being C. Connect these 2 points. The length from first position, the top view length from first position does not change even in the second position. Okay, since when you are seeing from the top, initially it was like this. You would have projected the triangle as a straight line. Now this straight line, whenever I give an inclination, it is still the same length, but there is an inclination. But in the top view, it is getting changed to an equilateral triangle. Okay, and this should be a clear view. Somewhere I have posted the pic on the top left. You can observe that as well. Okay, so we have maintained the same length. Now in the third condition, it says that the side that is parallel to VP is inclined at 45 degrees to HP. So which is the side that is parallel to VP? The side that hasn't changed its length from first position to second position. That is the side or edge which is parallel. If you observe, when I give inclination like this, since this edge is parallel to the sheet of paper, it doesn't change in its length. The projected length remains the same even though the inclination varies. Okay. Hence, this edge is now going to make a 45-degree angle. Okay. In order to draw that, we will again rotate it anti-clockwise. So, in order to place it anti-clockwise, let me use a protractor sufficiently away, mark a point, and on that point mark 45 degrees to HP from the left end. 45. Join this with a 2H pencil to denote the 45-degree marking line. Okay. Now the same equilateral triangle will rotate and rest on the 45-degree line that has been drawn. So this is 45. So I'll measure B dash should rest on HP. I'll measure the length. From this point, I'll cut an arc on the 45-degree marking line, and also I'll draw one more arc to obtain C dash. From the intersection of 45-degree line and the arc, again I'll cut an arc. So intersection of two arcs will give me the position C dash. Arc and the 45-degree line intersection will give me A dash, and this will be B dash. Join A dash, B dash, C dash. With a 2B pencil. Okay. Now draw the projections to obtain the final view. From C dash, I'll draw a line. from B dash till B dash, from A dash till A dash. So from this XY line, draw a line parallel AB from AB to A dash B dash, from C and C dash. Okay, so I'll erase off the excess projection lines that are drawn, and I'll limit to the intersection of the lines. So this is B, this is A, this will be C. Connect ABC with a 2B pencil to obtain the final projected diagonal. Now there is one more thing that remains. It asks for what is the angle at which the plane is inclined to VP. This angle needs to be measured, and it's 46 to me, 45, 46. Okay, it's 47 degrees outright to me. I'll mark it as 47. Okay, this completes the solution. Thank you for watching. Please do like, subscribe, and also share. In the next session, we will move on to a new geometrical figure, that is a square. Okay, thank you.